Hello, welcome everyone to another video of my PNS series of videos. Today we will make a little vibrato plugin. So the first thing we need for a vibrato plugin is a class we call vibrato. And this vibrato class will have a feed-forward delay. So what does a feed-forward delay have? It has an array of samples and a size. So when you init it, let's make it like this. It has a resize function where you give it a new size. We put 1 on the size of the length of the feedback, so that we can actually use interpolation methods that go a little bit higher. And we also keep the max value, which is 1 less. Now actually we need to get 1 back. And yeah, let's say we get the indexes from the other class. Now, of course, our index is a double value and not an int, so we can't use it to index in here like this. For now, we will just use no interpolation at all. Just do it like this. So yeah, we have a little feed-forward delay now, and we can use it. Now we can actually change the size of the delay. So let's make an object of that. Actually 2 objects, because we want to work in stereo. So we want to process some input sample and get a new output sample out of it. And if we have a stereo setup, then we also want it to for the second channel. All right. So we need this processing method. Okay, now we need a write index and we need a read index. Now when constructing the vibrato, we need to make sure they are on the default value. actually let's put that into resize. So we can just say resize, and if the resize default argument is 0, then we can just say resize and nothing else. Or even better, let's say we have a size in here and the default argument is 0, then it will be put here, and now we have the option to instantiate this with a size or not. Of course, it makes sense to actually do that with a size, so we need a function for that. Now we have a function that can translate milliseconds to samples. So we can do that here. Let's say we have 20 milliseconds buffer. And we have the size here, we can give it to our objects. Okay, now the vibrato knows how big it should be, and we can, I think we can actually do something now, which is just testing if everything works yet, which would mean delay. Oops, what have I done? Okay, we just return the delay, processing the sample with our right index and our right index again. This should return just the dry signal, of course, but we have to increment the dry signal now, since we are talking about a ring buffer here. So let's just make an increment function. Actually, it would have made more sense to save the size in here instead of inside of the delay. Okay. Because then we can do this. Let's put it in front of this. So we always make sure that we stay in bounds, no matter what kind of nonsense we make. Yeah, so now I have to change this, obviously. Maybe let's make this work like this now. Oops. Okay, now that's correct. Now the delay doesn't need such a fancy method anymore. Let's ditch this completely and instead just do this. And this can stay the same for now, but we don't need these anymore. Cool. That really simplifies a bunch of stuff in here. Yeah. Okay, let's try that. Everything works perfectly, I guess. Now we need a sine wave oscillator. Let's call it oscillator. We don't make it too complicated. We have a phase and we have an increment value, and I guess that's it. Let's set a frequency. This should be something like wait up. I need to write the other function first. The processing function. takes phase to inf, and if phase is bigger than tau, then phase minus tau, because that means tau is 2p, which is here, right? Okay. Now we can return. Oh yeah, right. It's a double. Return sign of phase. Yeah. Of course, now we have to care for the frequency a bit, because the frequency works a bit differently than I usually write my oscillators. This is the first time that I tried like this, and I don't want to waste your time in this video. So let me just take the script where I wrote it already and put it on another screen so I can check it out. Ah yeah, right. Okay, then the frequency obviously seems to be set by saying tau times frequency divided by sample rate. Yeah, because what I usually always did is multiplying phase with p in here, and then the frequency function is also different. I always thought that's easier, because then it means that you have a normalized sine wave in here. But actually this is computationally better, because you don't calculate new frequencies as often as you calculate new phases, I guess. Well, at least that's what I hope, except if you apply an oscillator on an oscillator, maybe as an LFO or something. Alright, we have an oscillator now. Now let's make an LFO. An LFO is not meant to just oscillate around -1 and 1, but actually around some value that you can define. And in order to make that happen, we have to define a range. A range has a start point, an end, and a range, or an interval. Interval, yes. Totally stealing the idea of juice here. But I really want to bring this in here. I wish there were initializer lists though. Okay, now the program knows what a range is. So for the LFO we can just say it has a range, and when the LFO is constructed we can say double start, double end, start gleich start. Actually, can I just do this? I guess I can. Or can I not? I'm always not sure in AngelScript if something like that works. Let's make it a little bit more obvious. Instead of making it like this, set range. Let's make standards in here, in case I want to actually use it like this. Set range now works like this, basically the same, but as a function. Okay, so now we don't have to test if the other thing would have worked, and can just say range set range start end. Okay, now we have a range, and now we must be able to set the frequency, of course, because we have an oscillator. now we can set the frequency, and of course now we want to process some data. We can just go return range start plus range interval times oscillator process, like this. Yeah, we have to put this into brackets to get a normalized value from this. You know, one that goes like this. One between 0 and 1, and then we use the range start and the end. Yeah, I would like to, oh, okay. Of course, I need to use other letters because otherwise things, I mean E. And we have the interval, which is this. And now we have start plus interval times this. Actually, I forgot to do this. Yeah. Now we can really see how we can define the start and the end point of the sine wave. Okay, now we can use the LFO in various ways. So we can put an LFO in here. And what were the things that we have to do for the LFO? We have to set a range. Of course, we didn't do that again. So let's also in here just set something like this. Yeah. Actually, we want to define the range from the vibrato. So let's rather give it as an argument instead of having it in the LFO itself. So we don't have to instantiate the LFO like this. Makes it a little bit easier. Okay, cool. Yes. Now we have a little LFO and we can process it, but therefore we now have to give it a range. So we have to have a range in here. And now let's pretend like we want the range to go the full way. The full buffer length of the plugin. In that case, we don't want to return anything now. We want to use the LFO to calculate a read index. I mean. What do we have to do for that? Now let's imagine we have some kind of let's call it T index for now. Or should we always call it R index? Yeah. R index equals LFO process, and now we give it the range. Range. But what actually is the range? I would say the range is let's say we have a delay. Set depth. We can set the depth now. A value between 0 and 1. Yeah, that's a cool way to make it. I just had to think a bit because I have it differently in my own implementation on the other side, but I actually like this more because now we can just say at the beginning of our instantiating, we say range start is always 0 or maybe 1 to be safe. No, 0. Let's just do this. And it's been set to 0 anyway when we set the range. Forget about this. Range. Set range is 0 to d times size. So now we have the full range with our depth. We have to remember that we have to set the depth as well. Now it will actually process the LFO on that range, and now we have to say our index is our right index minus itself, and this can bring our index below 0. And now we should be able to process the delay with our index instead and get a nice sound. Even without interpolation, shouldn't be too bad. Of course, something fails like always. 65. Okay. 65 set frequency. Oh, of course. Okay, we didn't set a depth in yet, so let's add this parameter. Now we have the depth, and we can just set it. Now, of course, we could make it even better if we put the range outside of the vibrato, so we don't have to have 2 range objects for each, but let's just ignore that for now. And we can already hear something happening, but we haven't set the frequency yet. We don't even know what frequency this is currently running at. It could be undefined behavior, so let's just make something like maximum frequency of 7 maybe, and now we can set the frequency as well. Oh, I must have made a mistake. No set frequency. Really? I did not make a set frequency yet, okay. LFO. Okay. It's a little bit not very tidied up here. You can see a lot of stuff when everything is so far away. Okay. Looks good. Actually, let's make all that a little bit smaller so we can navigate better when we go on. And as you can hear, even though we didn't use any interpolation yet, this already sounds pretty cool and very legit. So now we can go on and make a width parameter. And what would a width parameter do in here? It would, let's make it normalized. It would just put an offset on the oscillator, on one of the oscillators, only one of them. So let's call it set offset. Now we have to implement this. Now we have to implement the offset into the LFO. And as we can see, the LFO also does not have anything to offer for us. So we go down to the oscillator and actually apply the offset to the oscillator. So now we have an offset. Actually, let's give this a bunch of default values here, so we don't have undefined behavior anymore. And now we can just say plus offset in here. But what's the offset? At the moment it's just a value between 0 and 1. Now if we look at a normal sine wave again, then we remember that we have a wavelength between 0 and tau. So if we have an offset now, let's say goes between 0 and tau, then we can shift this around, but a full shift would be the same wave again. So instead of using tau in here, we only use p. So we get the maximum width like this and the minimum width like this. Now let's try this. Now we can change the maximum depth, because it's rather hard, by just reducing the buffer size. Now we hear a bit of clicking when we turn up the depth to 100%. That's because we sometimes go right index minus size completely and end up at the right index again. So in order to not do that, we could or we should actually fix that. Let's say set depth at the moment is d times size. Instead it's d times max now. Of course, this is not completely 10 milliseconds anymore. Now this is 10 milliseconds minus one sample, but I mean that's almost the same. Now the only thing to make this really nice now that could still be missing is maybe a mix knob. Let's also implement that into our little vibrato. Now we can return the normal sample times mix the thing minus the normal sample, and now we can set a mix. The default value of the mix should be 0 because obviously if you don't want to implement a mix, it should just do nothing. Cool. But we actually want to implement that. Oh, that's a different thing. So we can have a little bit fun with it. See how it sounds with the dry signal together. Process parameters. Okay. Yeah, that's pretty cool, I guess. One thing I really wonder though is, let's also do this in this video, I have a good one, which is how does this sound in mid-side, right? So let's just really quickly make a mid-side D and encoder. Of course, that also only works on stereo tracks now, but who cares? Left and right. And now we have our mid signal on here. And we have our side signal on here. Minus. Yes, I think that was it. Yes. Now we must make a method for decoding. Oh, what was encode? What decode? Whatever. If I used the terms the wrong direction, then I'm sorry about that. MS, and now this should be easier. Just put them back together. Oh, however that sound worked. Yeah, cool. Mid-side. Now let's try this, actually. And decode. Alright, let's go. Okay, something failed. Why? 69. 69. Oh, I'm so dumb. Okay. Of course. All right. Honestly, I can not hear the difference between with and not with, so this does not seem to be an effect that has a meaningful mid-side sound quality or something, or I just made a mistake with the mid-side thing since I'm working pretty fast. But I guess this is enough for one video, so goodbye.